We'll wait for some more minutes and we'll start the session. Okay, so shall we start the session? Hello?
I am ready whenever you tell me.
Okay, sir. Okay.
Okay, sir. Sir,
So
we'll
we'll,
start the session.
yes, okay. Just tell me whether my screen is visible or not.
Yes, yes, it's visible.
Okay, so we'll start the session. Good afternoon, all. A very warm welcome to our today's session. Today is the fourth day of the Color Week 2020. I am Rugved Upadhyay, host of today's session. Our today's topic is instruments used in color measurement, and our today's speaker and guest is Mr. Vishnuu Kamat, sir. Before starting the session, I would like to announce our yesterday's quiz winners. Sainik Guge, BE Printing, Ganesh Sheke, TE Printing, Sharad Hange, BE Printing, Sanket Dhemre, BE Printing, Ashutosh Kaye, E Printing. Congratulations to all the winners. To others, even if your name is not in this list yet, we still got 3 more sessions. So don't lose your hope. We'll fight together. Now, let's revise what we have learned in last 3 days. Day 1, Fundamentals of Color Science by Mr. Narendra Gangakhedkar, sir. Day 2, Transformation of Color by Mr. Ravi Vaidyanathan. Day 3, Basics of Color Management and Process Standardization by Mr. Das Damodaran. Now, starting the session, I would like to invite Sandesh to introduce our today's guest, Mr. Vishnuu Kamath, sir. Over to you, Sandesh.
Thank you, Rugved. Good evening, everyone. Myself, Sandesh Lindve. I am going to introduce our today's speaker, Mr. Vishnuu Kamath, sir. Mr. Vishnuu Kamath, sir, is the Senior Vice President at Advanced Graphic Solutions Transact Technologies, Mumbai, which is one of the leading provider of digital payment solutions and automation technology in India. He is a chemistry graduate from Ruia College, Mumbai. Further completed the post-graduation in paint technology from the prestigious VGTI College, Mumbai. He joined AGS Transact Technologies in 1999. starting with handling the spectrophotometer products for the paint, plastic, automobile industry. While working in AGS, he completed the Masters in Marketing Management from Mumbai University to Wellinkar College of Mumbai. Last 16 years, he has been actively involved in the industry, supporting all customers for the requirements of color measurement and color management and other products. He has been working since 21 years from being an applicant engineer to a senior vice president. Over to you, Rugvit.
Thank you, Sandesh. That was a great introduction of Sir. Now, I would like to invite our today's guest, Mr. Vishnu Kamat Sir, to start with their presentation.
Thank you, Rubik.
Yes, sir. Just one sec. I will stop my sharing.
Yeah, please.
Yes. Sir.
Hello, sir. Pitala here. I'm sorry I got a bit delayed. I was in
No problem,
another
ma'am.
meeting.
Good
Yeah.
evening to you.
Sorry. Yeah.
Is my screen being seen to you?
Yes, sir.
Is it clear now?
Yes, sir. It is visible.
Okay. Good evening to all. My name is Vishnuu Kamat. I'm coming from a company called as Advanced Graphic Systems or AGS Transact Technologies Limited. I have been a part of this organization for the last 21 years and have been handling the printing industry products for the last 16 years with AGS. So, like you guys, I was just out of college when I finished my paint technology from VJTI Mumbai. And that's how I directly got into this beautiful company called as AGS, with whom I have been working for the last 21 years. So, I was invited by Madam to come and give you some little knowledge that I have about color and color instrumentation. I just saw that you have already been through a lot of presentations by quite a few known personalities in the industry. So I'll be touching upon maybe a different concept called as instrumentation, right? Because today in the industry, everything is about instruments. Everything is about changing from visual perception or visual assessment to digital assessment. Even today, if you look at it, probably this seminar would have been a physical presence of me in your college giving your presentation. But today we are going digital because of the current situation. It's all about digitalization of the whole process. Even the printing industry went through the same process over the last so many years. Just to start with, I'll again refresh you some details about color. Just 2-3 slides. I'm sure you would have seen this earlier from the earlier presentations from the gentlemen from the industry. Color is a very small part of something called an electromagnetic spectrum. Electromagnetic spectrum consists of a lot of things, which is right from electromagnetic rays to X-rays to infrared to UV to a lot of different radiations, out of which color is just a very small part that you see over here. That is something that only a human eye can see. You cannot see anything in the electromagnetic spectrum other than this small region, which is called as the visible region. Now, this visible region basically goes from 400 nanometers to 700 nanometers, covering 7 colors that we know, which is called as the VIBGYOR or however you pronounce it, which is violet, indigo, blue, green, yellow, orange, red. So we are what human eye can see is a very, very, very small part of the whole electromagnetic spectrum. This is how I see the color. You have a light source, you have a substrate, the light falls on the substrate, a part of this light gets absorbed by the material, a part of it gets reflected, and the light which gets reflected is seen by the human eye. And that's how you interpret it as a particular color. Now, the most widely used technique to understand color is the CIE system, which is nothing but the LAB values, the LABCH values. Probably this you would have seen probably in the earlier presentations. This is basically called as a hue circle, where you have the LAB, this is the L, this is the A, and that's the B, okay? That's the LAB, okay, which is nothing but L stands for light dark, A stands for red green, B stands for yellow and blue, C is nothing but chroma or the saturation of color, and H is nothing but the hue angle, which is again nothing but violet, indigo, blue, green, yellow, orange, and red. So let me just talk about, I didn't want to touch about too many things on color because I think I was pretty sure that it must have been covered by the earlier speakers. Just giving you a small brief about what color is, let me go directly into some basic components of something called as densitometers and spectrophotometers. Now, this particular perception of color that you saw over here, where there's a light source, a substrate, and an eye, this whole concept has been converted into instrumentations. Now, the two commonly used instruments in the industry are called as densitometers and spectrophotometers. It is very important for all of us to know what is the difference between them, because unfortunately, even today, people commonly call a device as a densitometer, but probably it is actually a spectrophotometer and not a densitometer. So maybe when I go through the next 2-3 slides, I believe that point should be clear to you. What is the difference between a densitometer and a spectrophotometer? Now, what are the basic components of a densitometer? A light source, which is obvious because otherwise which you cannot see a color. A illuminating angle, which is nothing but the angle at which you see the color. Obviously, the optics through which the light passes through. The filter and something called the receiver. Okay, the receiver is nothing but the human eye. Okay, the filter is nothing but, for our understanding, in our eye, we have something called as rods and cones, which define the intensity of the light and the color that you're seeing. That's kind of a filter for you, right? This is how a typical densitometer would look. You have the substrate over here. You have the light source over here. The light falls on the substrate, okay, and gets reflected out. That's the filter, and that's the receiver, right? So this is how a basic densitometer is set. Now you would see that over here, the densitometer you see basically has 3 filters. Sorry, I guess I just got stuck up somewhere. Just 1 second. Okay. So here if you see, you can see 3 filters called as red, green, and blue. Now a densitometer is a device which can only measure cyan, magenta, yellow, and black. Please remember this particular difference between a densitometer and a spectrophotometer. A densitometer is a device which only measures CMYK colors. That is cyan, magenta, yellow, and black. But the moment you give it any special color or a cut color, or which is also called as a Pantone color, then a densitometer does not understand that color, because the measurement of the color in a densitometer happens using only three filters, which is red, green, and blue. The most important device for us today in the industry per se is a spectrophotometer, and that also a reflectance spectrophotometer. There are different kinds of spectrophotometers. You have a transmission spectrophotometer as well as reflection. I'll basically touch upon reflection only because today, practically in the printing industry, we don't use transmission spectrophotometers at all. We do use something called as the transmission densitometer, which is normally used to measure your positive films, which again today is kind of getting into a legacy or a history kind of thing, because with the advent of CTPs coming in offset, you don't use films. So again, transmission densitometer is not used very popularly. So coming back to the point, a reflection spectrophotometer. This is all that we use today in the industry. Again, it consists of a light source, a illuminating viewing condition, which is nothing but the angle, a monochromator, which is similar to the filter in a densitometer, and a detector, which is nothing but your eyes. Okay, so that's the basic component of a spectrophotometer. Now, just hold on for a second. Yeah, just hold on for a second. Okay, sorry, is the presentation visible?
Yes, sir.
Okay, sorry for the break. So, when you talk about reflection spectrophotometers, it is very important for you to know that in the industry, or let me put it this way, in the printing industry per se, we use two kind of reflectance spectrophotometers. One, which is something called as a 45 0 degree or a 045 degree geometry instrument, and secondly, something called as a diffuse 8-degree geometry instrument. These are the two popularly used devices in the industry. Today, in your setup in PVG, you have two devices, if I remember it correctly. One is a device called as a Spectro I, which is a violet color device, and a device called as the I1, which is a gray color device. Now, both these devices are based on the 45 0-degree geometry. This is the most commonly used device in the printing industry. 90% of the industry uses a 45 0-degree geometry instrument. Very simple to understand. When I say 45 0, you always need to understand that the first angle is always the illuminating angle, and the second angle is always the viewing angle. So the 45 degree is the illuminating angle, and the 0 degree is the viewing angle. That means if you have a substrate, there is a light source at a 45 degree angle. That light falls on the substrate, and the light goes out into the detector of the instrument at 0 degrees. And hence, this instrument is called as a 45 0-degree or a 045 degree. Means at 0, there is the light source or its illuminating angle, and 45 degree is the viewing angle. Similarly, there's a device called as the diffuse 8-degree geometry instrument. Now here, you see that there is a sphere over here. This sphere is basically coated with a white material, which is supposed to be the most whitest material in a stable form available, okay, which is similar to something called as a magnesium oxide. Now here there's a light source which when flashes falls on this white particular sphere. Since the sphere is white, the light gets diffused, so the illuminating angle is diffuse. Now this light which now falls on the specimen or the sample goes out of this sphere at 8 degrees, and hence the viewing angle is called as 8 degrees. So this type of device is called as a diffuse 8-degree geometry device. Now where these two are used and for what application they are used, we will come to know as we go ahead. But as a thumb rule, you need to understand that there is a device which is a 45 0-degree geometry instrument and a device which is a diffuse 8-degree geometry. This is a thumb rule that you need to remember and memorize and never forget until you are in the industry of color. Now, giving you a basic about what was color, what are the different types of instruments, a densitometer, a spectrophotometer, and what are the different types of spectrophotometers. Now let's get into the spectrophotometers. Now, a spectrophotometer is a device which can measure all the colors of the visible region spectrum. As I mentioned, densitometer can only do CM by K. A spectrophotometer can measure all the Pantone colors, or let me put it very simply, all the colors that a human eye can see, including the CM by K. Right? Now, that's the reason why today in the industry, people very rarely use a densitometer and they very widely use a spectrophotometer. One more reason for that, because today the spectrophotometers can also measure all the densitometric functions. When I say densitometric functions, means all the functions that the densitometer can measure, like density, dot gain, trapping, gray balance. All these are basically terminologies used for measuring the dot value and the density of the printed dot on your printing press. Now, the spectrophotometer that we are talking about today in the industry in general can also measure these functions. So, you can also call the spectrophotometer as a spectrodensitometer. So, either you call it as a spectrophotometer or a spectrodensitometer, spectrodensitometer, both are absolutely correct. Now here, I've given you an example of a device called as the Exact. Now this Exact is one of the most commonly used devices today in the industry. The most popularly used device from a company called as X-Rite. X-Rite is a US-based company and the leading supplier of these devices in the industry. This device is based on a 45 0-degree geometry. Now I guess it's clear to you that what is the 45 0-degree geometry? They are basically a portable device and battery operated. So you can carry the device wherever you want and even place it on a printing press as shown over here and measure your color on the press. This device basically has a touch screen functioning, and here on the device you can see it has an onboard quality control software. So the moment you measure the color, the onboard quality control software will automatically display all the functionalities like density, dot gain, trapping, gray balance, LAB, LCH, delta E, and many more features like whiteness index of the white substrate, or maybe the strength of an ink, or the opacity of an ink. Now, I don't know whether you guys know what is the strength, opacity, or whiteness, but these are also parameters which are measured using a spectrophotometer. So, the first most widely used device, which is a spectrodensitometer, is called as an exact device. I mean, an example given over here, which has a 45 0-degree geometry as the geometry of the device. The second device in the industry which works on a 45 0-degree geometry is called as the I1. This is very similar to the I1 device that you guys have with you, which is used to create your ICC profiles. Now, it's very important for you to understand the difference between the two. An exact kind of device is basically a spectrophotometer or a spectrodensitometer used on the shop floor for measuring your printed sheets. Because it has an onboard quality control software, it gives you the result immediately. The I1 is a device which is also based on a 45 0-degree geometry instrument, but is used purely in the pre-press department and is not supposed to be used on the press room floor. This device is used to create ICC profiles, or for doing, in general, you call it as profiling of monitors, offset presses, digital or inkjet printers, scanners, projectors. Now, all these devices can be calibrated and profiled using this device called as the I1. Now, this cannot be done by the device which is used on the shop floor, which is nothing but the exact, which is an example given over here. Now, if you see, this device does not have an onboard quality control software. So this device has to be connected to a computer before you can use it. While the exact doesn't need a computer to be connected to it because it has an onboard quality control software. Now, this difference, as students coming out of college and going into the industry, is very important for you to know, because tomorrow you may get a chance to choose for your company where you work that which device you need to buy. So you need to be clear which device is used for what application. Moving ahead, the next device. Now, this device is based on the diffuse 8-degree geometry that we spoke about. This is again a portable device and a battery operated. You could carry this device anywhere and everywhere that you want. Now, and also used very well in the printing industry. A few important differences between the exact that you saw and the CI62 model which I've mentioned over here. Both are used in the printing industry. Both are used on the shop floor. What are the differences? The exact is used, the exact is a 45 0-degree geometry instrument, while the CI62 is a diffuse 8-degree geometry instrument. First difference. Second major difference, the exact kind of device cannot, please mark, remember and memorize what I'm saying. The exact kind of device, which is a 45 0-degree geometry instrument, cannot measure surfaces which are highly reflective. When I say highly reflective, it means metallized polyester substrates, aluminum substrates, and metal-based substrates. while the CI62 is used in the industry and by companies or by organizations which specifically do printing on MetPet, which specifically do printing on aluminum and metal substrates. This also is called as UV printing. I'm sure most of you guys would have heard about UV printing. UV printing is nothing but printing of the inks and drying it using the UV lamps. And most of this UV printing happens on MetPet and aluminum substrates sometimes. Mainly MetPet, sometimes aluminum. For such kind of applications in the industry, you need to use a diffuse 8-degree geometry instrument only. You cannot use a 45-0-degree geometry instrument. Going ahead, some other kind of spectrophotometers which are used for automation of offset printing presses. Here the device that you see is nothing but the exact, which again goes with a 45-0-degree geometry instrument used on the shop floor for measuring color. But here we have converted the device into an auto scanning. Means this device can be placed on a track and you could measure the whole sheet with a control strip within less than 8 to 10 seconds. Maybe I have a video next. I really don't know how this video would be played, but let's hope that you can understand the video. Was the video clear to all of you? I don't know.
Yes, sir. It was clear.
Wonderful, wonderful. Okay, that's great. So that was the device called as AutoScan. There's one more device in the industry which is used for auto scanning called as the IntelliTrax 2. Now it does exactly the same way, the same work as what the exact auto scan does. But one important factor about this device is that this is completely a non-contact device. In the earlier video, you must have seen that there was a wheel which is touching the printed sheet. While here, the IntelliTrax 2 does not touch the sheet at all. It is completely a non-contact measurement. Again, let me run a video for you. Here, I would just like to add something in the video. Why the auto scanning is so important in the industry today? Because when you talk about an offset printing press, I'm sure most of you would have seen an offset printing press. It has anywhere between 23 to 32 keys. Now, for any operator to adjust a color on the press, he needs to play around with all these 32 keys of each and every color. Now, this particular device, the exact auto scan, or the IntelliTrax, which is the auto scanning device in the industry, basically gives you information about every individual ink key zones of the printing press. So here you can see an information from key number 2 to key number 31 of the printing press. And this information comes to you in less than 10 seconds. So one measurement and you get all the information about all the colors that you're printing. If it's a 4-color press, then you get 4 rows and 32 columns. If you have a 5 or a 6-color press, then you will see 6 rows and 32 columns. So this basically gives a faster correction that you can do on a printing press. So this here you can see that the earlier screen was completely red, and after that you see a completely green. That indicates that your colors are exactly matching to your reference sheet. And your production is going very, very, very smooth. So that was about the auto scanning. Now, this slide I have put over here is something that is actually not used in the printing industry, but is something that you should know about. This is a third type of spectrophotometer called as the multi-angle spectrophotometer. Now in this device, or let me put it this way, this device is widely used in the automobile industry, where the car has different parts to it. So for example, a door comes from a different factory, the body comes from a different factory, the bumper comes from a different factory, but when it comes to a single car, they should look the same. Now in today's times, you must have seen that practically every car that you see is not a solid color. It is a metallic color based paint, or it is a pearlescent color based paint. Now these kind of pigments which use pearlescent or aluminium flakes to it, which are also called as metallic paints, like we have metallic inks in the printing industry, there's something called as metallic paints. Now these paints can only be measured using a multi-angle spectrophotometer. In any of the earlier devices that you saw, which had a 45 0-degree geometry or a diffuse 8-degree geometry, there was only one angle of measurement. But in a multi-angle spectrophotometer, you can go right from 5 angles to 12 different angles of measurement. We do not use such kind of devices in the printing industry, but I thought it was important for you as students to know that even these kind of devices do exist. Some small information about also something called as an offset plate reader. Today in the industry, everybody talks about CTP, that is computer to plates. where you put a plate, you send your design, and the CTP, which is the computer to plate machine, directly transfers the image onto the plate. Now, it is very important for you to check whether the dot on the plate is right or wrong. Because if there is a dot gain which has happened on the plate, then on the printing press, there is going to be a further dot gain, which is not good for you. If there's a dot loss when you're making the plate, again, when you go to the printing press, it's not good for you. So it is very important that at the plate level in the pre-press department, when you're making an offset plate, you need to check whether the dot engraved on that particular plate is the right dot that you need or not. And to do that, you use something called as a plate reader. This device is only and only used for measuring offset plates in the offset printing industry and is based on a CCD camera based technology. They're not based on a spectrophotometer technology, which is a 45-0 degree or a diffuse 8-degree geometry, but they are basically CCD cameras inside, which take a very, very, very high resolution image of your plate and then analyze the plate and tell you that whether the dot of a 5% is a 5% or a dot of a 50% is a 50% or not. Going ahead, I thought it was also important for you to know that there are certain softwares which are very commonly used today in the printing industry, especially for something called as an ink kitchen. This word, ink kitchen, must be very commonly heard by all the students, but probably they don't know what is the part of the ink kitchen. Now, an ink kitchen has many things, like a weighing balance, a mixer, a stirrer, a lot of things. But one of the most important part of an ink kitchen are two things. One, a spectrophotometer, and second, a ink formulation software. Now, the spectrophotometer choice, which I showed to you, a 45-0 degree geometry like an exact, or a diffuse 8-degree geometry like a CI62, has to be checked by the company based on what kind of printing that they do. If they do normal printing on monocarton boards and everything, then the instrument or the spectrophotometer in an ink kitchen would be an exact. But if they use or print on MetPet or aluminium or metal substrates, then the instrument in the ink kitchen is going to be a CI62 device. But the software for both these devices is the same, which is called as the ink formulation software, or in short is called as the IFS. It's a very simple software where, based on the color desired by you, you can use the spectrophotometer to measure the color, and the software will automatically give you a recipe or a formula how to make that color. For example, over here you see a pink color, and the software says you need to add yellow, rubine red, rhodamine red, and a transparent white. The total is 100 grams, kgs, whatever. The moment you mix this color, the software says you should get this particular pink color. Today, again, in the industry, people use visual methods to match color, where the person doing the matching will look at the color and say, okay, fine, this color would need white, blue, green, and maybe a bit of white. But he doesn't know what quantities. he would do a lot of trial and error to come to that color. But with an ink formulation software coupled up with a spectrophotometer, it becomes like a child's play. You just click a button and the software will give you a recipe for that. The next software very popularly used, if you remember when I spoke about a few slides back about a device called as I1, which is popularly used to make profiling or ICC profiles for monitors, offset presses, digital printers, inkjet printers, scanners. Now, that device will be coupled up with a software called as the iProfiler Publish Pro. The iProfiler Publish Pro is a software which connects to this I1 and will help you create these ICC profiles, or will help you to profile your monitors, your scanners, your printers, and everything, for which you need to print such kind of charts. Now, these charts can be printed using your offset printing press or your digital printer or your inkjet printers. Once you print these charts, you use the I1, measure these charts into the iProfiler software, and then the software will help you create the ICC profiles. As I said, the software helps you to create profiles for all these devices: monitors, printers, scanners, and projectors. One more important thing today, which is getting more common in the industry, are visual assessment light booths. Today, even today, when you're doing some kind of lab working, and if I tell you to look at a color, you look at the color in the light in your laboratory, which could be a tube light, which could be a halogen light, which is the yellow light, or which could be a fluorescent lamp. Now, we need to understand one thing very clearly as technologists, printing technologists coming out of college, going to the industry. We need to understand one thing very important, that a standard and a sample may look matching or pass under one light, but may still look different or fail under some other light. Means, for example, if you have a standard and a sample which you are viewing in a daylight outside in the morning time outside, you will see that, oh, the color is perfectly a match. But let's assume the moment you come inside your laboratory and you again see the color, you will see, oh, I see a difference. Now, this is a very common phenomenon in the industry called as metamerism. Metamerism is a phenomenon where a standard and a sample look different under different lighting conditions and can pass under one light but may fail under another light. Now, to handle this effect of metamerism visually, you have these light booths. These light booths have different lighting conditions in them with a neutral surrounding background. Now, why a neutral surrounding background? Because probably you'll see that when your background is green and you're seeing a green color, you will see that the green color looks more greener to you. So your surrounding color also affects the way you see color. And hence, these light booths have a neutral color, which is basically something called as a Munsell N7 gray. Munsell again is a product from X-Rite, and Munsell N7 gray is the most neutral color available on the earth. Means it has no red, no green, no yellow, no blue tones. They are purely gray. And these light booths have anywhere between 5 to 6 different lighting conditions, where you can keep your samples inside and see the color. Here, I'm just touching about a few more spectrophotometers used in the industry, which I've not spoken about, and I'm not going to talk more about them. But again, as students and people coming out into the industry, you should know that whatever I spoke about the instruments are not the only instruments in the industry. There are other devices also which are used in the industry for markets like paint, plastic, textile, cosmetics, paper. Now, these are all the other devices. We do not use them in the printing industry, but they are very popularly used in the above mentioned industries. They are all spectrophotometers, which help you to measure color, which is nothing but LAB, LABCH, and delta E values. Now, when we have spoken so much about color, we have spoken about visual assessment of color. We should also know that not everyone is gifted to see color the way one should see. Every person does have some kind of color deficiency in their eye. When I say color deficiency, it means that you may or may not be able to see certain colors. Sometimes it is also called as color blindness. Now, to test color blindness of individuals, there are certain tests in the industry. One is a Deverin book of pseudochromatic plates, where I don't know whether you can see something, a number on this plate. Can someone tell me what number it is?
32.
32.
32.
Oh, now I know everybody's going to say 32. Yeah, the first one gets it. Okay. Anyways, you're right. 32 is the number. But somebody who is a color blind in red and green will not be able to see this color. He will see everything as gray. This is one way of testing color deficiency or color blindness. And second is something called as a Farnsworth-Munsell 100U test. This is also one of the most standard tests in the industry. In fact, a lot of big companies in the color industry, when you're joining in the color laboratory, they test you for this before they recruit you to join the company. Because if you're a color technologist going into a color lab and you can't see a color, then you have no job over there. So that's about from me. I think I did take about 45 minutes, I think. I was given a time of 40 minutes. So sorry for the additional 5 minutes. But
No, sir.
I think I tried to cover most things related to the spectrophotometers and everything. So, I mean, now if you have some questions for me, then please let me know and I'll be glad to answer them.
You see, if anyone have question, they can drop in comment box.
I hope, madam, the presentation was good enough for
Yes,
everybody
sir.
to understand.
No, sir, it was very much interesting, and they must have learned so many small things. Like they just see the instrument, but they don't know, like how industry it is going to be used in industry, or am I
Absolutely,
going to use
absolutely.
the industry? Yeah, it was really nice.
That was my basic intention, to
Yes,
inform all the students over here that what are the different categories of instruments used in the printing industry.
yes.
Yeah, so yeah, if you feel that I've covered it, then I'm grateful for that. Thank you so much.
No, we are happy. Like I'm very much happy to see whatever instruments that you have shown. We're really grateful. I have just one question. That auto scan instrument that shown. So it is not touching the substrate as such, right? It is, or it is the
It depends, ma'am. I showed two instruments.
yeah, the
One
second
was,
one,
the
not
second
the
one,
exact one, the other
which
one.
was the IntelliTrax 2, is
Yeah,
completely a non-contact device where no
right.
part of the head is touching the sheet.
Yes, yes. So is it not possible that ambient light might affect the
No,
region
no,
involved?
not at all. It is designed in a way that no ambient light can even touch it or can enter into the optics
Influence.
of the
Yeah.
device and give you a wrong result.
Okay.
It's
Okay.
not possible at all.
Okay. Okay. Rupit, I think we have one question.
Sir, I have one question. How does that IntelliTrax 2 device works?
Uh,
Like, what?
Rugved, can you just hold on for a second? Just one.
Yes.
Yeah, sorry. Yes, Rugved, tell me.
Yes, sir. How does that IntelliTrax 2 device works? Like, it is not contacting the surface, right? So does it emit some sort of light?
Yeah, Rugved, very simple. It is a spectrophotometer. When it's a spectrophotometer, if you remember the slide where I showed you the components of a spectrophotometer, it has a light source
Yes.
inside it. So the light source emits a light. There is a substrate below, which is the control strip, which is the substrate. The reflected light goes back into the device, into the detector, which detects the color. So it's a very simple process, like how a spectrophotometer works. Is basically a spectrophotometer.
Yes. Pratik Dandge has one question. Please tell more about diffuse 8 degree geometry spectrophotometer.
Yeah, I mean, I would like to know from Pratik, what more does he want to know? Because I could talk for hours, but then we don't have the time. If he has a specific question, I would love to answer it.
Yes, Pratik, you can unmute yourself and ask directly.
Hello, sir. Good evening.
Yes, Pratik, good evening.
Sir, actually, I heard that term first time, so I didn't get it first time when you
नाही ऍक्च्युली
explained me.
कोणाच त्याच्याबद्दल माहित नाहीये जास्त लोकांना बिकॉज आपल्या प्रिंटिंग इंडस्ट्रीमध्ये people don't use it so much.
Okay.
But now in the last about 5 years, the use of these kind of devices is growing because printing on METPET substrates is really increasing.
Okay.
Till 5-6 years back or 7 years back, METPET printing was not that great. We were still printing on normal substrates. So a normal spectrophotometer could be used, but with the advent of METPET printing, which makes your print look very beautiful, the need of also measuring that color came into picture. And hence this device. And to give you a small brief, if you know METPET or aluminium, they have very, very, very high gloss. Am I
Yes,
right?
sir. Yes.
Perfect. Now a 45-0 degree geometry instrument
Mm-hmm.
does not understand this gloss level.
Okay.
And hence, when that 45-0 degree geometry instrument measures the color on a METPET substrate, it sees the color as black.
Okay.
Because that basic color has about 70% as gloss.
Mm-hmm. Yes, sir.
It's difficult for you to understand. Probably if I would have been in front of you, I would have explained to you in a much better way. But in short, in a diffuser geometry instrument, the gloss level of the substrate is also measured along with the color.
Okay.
And hence, the diffuser geometry instrument is used for measuring of METPET substrates.
Yes, sir. Yes, sir. Okay.
I see one more question over here from Kaustubh, which says, what is the
Thank you,
need to invent 045 geometry if there is a 45 geometry spectrophotometer? Kaustubh, both are exactly the same. There is no difference at all. The readings also would be the same. It is just that a particular company wants to do 045, 45, 0. It is their decision, but technically both are the same.
Price wise
the-
also, sir.
Sorry?
Price wise also, like one instrument can be
Yeah.
interchanged to different geometry. Like no, right?
No, I mean, madam, there is actually hardly any device in the industry which is a 045.
Okay, right,
It's all 45 0 only, more or less.
right, right.
Vishnu
Shubham,
sir,
yeah.
Vishnu
Yes,
sir,
Akshay sir, namaskar.
Namaskar. I have one question.
Bolo na, sir.
In in flexible packaging line, when we print on reverse printing such as polyester and then we laminate with metped, so we have three layers, maybe 12 microns polyester, then we have 12 microns metped and 50 microns poly. And when we do the lamination, and after that, if the customer wants to see what color it comes according to him, so in that case, which type of an instrument would you suggest to be used?
Akshay sir, it all depends upon how you want to do it. A lot of people in the industry only check the reverse printed poly first, standardize on their color then and there, and just
Correct.
laminate then on the metped. In that case, a normal 45 0-degree geometry is more than sufficient.
Yes.
But again, if the reverse printed poly is a white and not a transparent, okay, then again the exact can be used. But let's understand a situation where the reverse printed poly is transparent and then you laminate it on the metped. In this case, for us, it is similar like a metped substrate.
Okay.
And hence, what you need is a diffuse 8-degree geometry instrument. But
Okay.
let's assume there's a situation where the reverse printed poly is a white, like an LDP, a white LDP or a white PP, which is laminated on a metped. Then probably we can still use the 45 0-degree geometry instrument for measurement, because the white color of the substrate is hiding the gloss of the metped.
Yes.
So a 45 0-degree instrument also should be good enough in that case.
Yeah. Sometimes the customer, they wants to see the color after the lamination process. Then I think what you said is right. Then in that case, the diffuse geometry should be used 8-degree.
Perfect.
After the lamination.
If the reverse printed is transparent, then yes, it is.
Yeah,
it
yeah,
is diffuse
transparent.
8-degree geometry. Yes.
Yeah.
Yes.
Okay. Thank you.
There's one more. Thank you, sir. Thank you so much for your question as well. There's one more question from Shubham. Which type of spectrophotometer should be used while measuring textile and which mode? So for textile, it is 100% a diffuse 8-degree geometry instrument. And when you say which mode, can you please elaborate? Shubham.
Sir, like M0, M1 mode, like.
No. So those in a spectrophotometer, which is a diffuse 8-degree geometry instrument, there are no modes or M factors at all. M factors are only applicable in the printing industry and specific to those devices which are made for the printing industry, like the exact. And it is not applicable for the diffuse 8-degree geometry instrument.
Okay.
There's one more question from Aditi as well. I think the answer remains the same. What would be used for measurement on textile? I think I did just mention that it is a diffuse 8-degree geometry instrument. And the model which I showed here during the presentation, the CI62. So Is there any more questions? Please. Any more questions? Akshay sir, any more questions? Srikala madam, any more questions?
No, from my side it's okay. Okay.
I think we have got one
Any
there.
questions from the student side, Srikala madam?
I have one more. No, no questions, sir. Not from me as well. I think Shubham sir, Joshi madam, if you want to ask something.
Yes, ma'am.
Mahajan
Am I
sir
audible
is
to
here.
you, Vishnu sir? Myself, Shubham Kharat from UVG COET.
शिवम साहेब थोडं मोठ्याने बोलाल का मला ऐकू येत नाहीये सर.
Okay, sir. Now, am I audible to you?
Yeah, better than the earlier. Please tell me,
Okay,
sir.
okay. Okay, sir. My question was when we are you mentioned that we are supposed to match the color of the interior parts of an automotive car with the body color, right?
Yeah.
So basically, these IMD parts or these interior parts are coated with some kind of layer, and they deal with some kind of gloss values, which are generally
Yeah.
measured with a glossometer or a gloss meter. Probably
Right.
the standard is BYK for all automotive sectors. So
Yeah.
now, what would you recommend if someone wants to match the color, not the gloss value? So they should play with the densitometric values of a color, or they should play with the gloss value of the coating or some kind of top layer of that part. Basically,
Shivam
they are
sir,
metallic inks.
see the gloss levels on the interior of a car, for that matter, that you mentioned right now, actually play a very, very small role compared to the color. Okay.
Okay.
Normally, this gloss part is a very a small part of the color. Okay. I would, as based on the experience working in the automobile industry before I started working for the printing industry, I used to go to every automobile manufacturer in India
Okay.
when I had joined AGS. For me, it is more of color, and even for the automobile manufacturer, it is more of the color. Let me put it this way, sir. Your standard is along with a gloss, your sample is also along with a gloss.
Okay.
What is important for them is to match that color. Now, that's where the people in the industry, in the automobile market as well, look at color more precisely and then look at the gloss level.
Okay, sir.
One big point about our CI62 model, which is a diffuse 8-degree geometry instrument, it also has something called as a co-related gloss. So it basically measures color and gloss of the standard, color and gloss of the sample, and gives you a difference for both.
Okay.
And hence comparison becomes very easy.
Okay,
I
sir.
hope I've been able to answer your question.
Yes. Okay.
Yeah,
Sir,
sir, I
probably,
have
sir,
one.
you might have worked with Motherson also, right? You might have
Yes.
worked with Mothersons also. They have always facing a problem to match their gloss level with respect to the sample provided by any automotive sector. Probably
Yeah.
they are giving a small plaque, maybe 4 by 4 inches, and they are just demanding for a color, let's say metallic gray or maybe warm gray. But the moment they match the color, they are not able to match the gloss value at the same time. You might
See,
have
here
made,
again, what comes into picture is whether it is just a plastic material or a plastic material coated with a paint.
okay.
So there's so many factors involved over here. Maybe next time when I come and meet you personally, maybe I can elaborate more on this.
Yeah, sure, sir, sure. We'll
Sure,
definitely
sure,
plan
sure.
and meet for this.
Yeah. Yes, madam, you're saying something?
Yeah, so I wanted to ask about the light booth that you have shown. The light
Yeah.
booth question. Like, if I'm asking one person whether the color, like, how to measure the light booth response, like, how to categorize it. Okay, these many people said it is not matching. These many people said this is matching, or
No. So light
how
booth is
to
purely
quantify
used
that.
for visual assessment of color. It is not for
Yeah.
any kind of analysis of individuals.
Right. But then
So
color expert will say whether it is matching or not.
Yes. So basically, what you need to do is that in the textile industry today, even if you match a color using a spectrophotometer,
Right.
they will still tell you to look at the color in the light booth and check if it matches under different lights.
Correct. Okay.
Because for a textile market, for example, uh, uh, you have two shirts which are there on the rack. You know,
Yeah.
in some stores it is a yellow light which falls on it. In some stores it is a green, it is a fluorescent light which falls on it.
Yes.
They want to ensure that in any light, their standard color and the sample done by the vendor matches.
Right. Okay.
And hence, a visual assessment light booth where you can keep the standard sample inside, change the different lights,
Right.
and see that in every light the color matches.
Okay.
But it is not to analyze an individual,
Right. Right.
it is to analyze the color under different lights.
Correct.
Yeah.
So if the color experts say that under fluorescent the color doesn't match, then the printer or the person who is working on the printing part will adjust the colors, whatever.
Yes, but
Yeah.
his visual assessment should also match to the instrumentation assessment.
Right. Right. Correct.
Get the point? If the instrument says that in the same light, because even in an
Okay.
instrument, which is a spectrophotometer, you can
Right.
find out metamerism there also.
Yes.
If in the instrument it says it is passing, and the visually that guy gentleman is saying it is failing, then
Right.
probably the gentleman has some problem looking at that color in that particular light,
Right. Okay.
or the instrument is wrong.
Okay.
That needs to be analyzed.
Okay. Fine. Fine.
But the visual assessment and the digital assessment have to be the same.
Correct. Then only it is completely passed. Otherwise,
Absolutely.
it has to be. Okay.
Absolutely. Absolutely.
Yes. Okay.
Anything more?
That's it.
Any more questions?
No, there are no questions in chat box, I suppose. No.
I saw that there are no more questions on the chat box.
Yes. Sarugwed, you want to proceed?
Yes, yes, ma'am. So thank you, sir. That was very informative. Uh, Now I would like to invite Professor Padmata Joshi ma'am to give her feedback on today's session.
Mm, Okay. Yes, thank you, Rugved. Am I audible?
Yes, ma'am. Yes.
Yeah, right. Namaskar, sir.
नमस्कार नमस्कार पद्मजा मॅडम कशा आहात तुम्ही
Bas ठीक. How are you, sir?
All well madam all
Yes. Working from home or started on the site actually?
I'm already traveling all over India again.
Okay. Okay. It is, I mean, all were asking the questions आणि माझ्या मनात एकच येत होतं की it would have been so nice की तुम्ही तुमचे instrument आणि with all the setup if you would have been in our institute it would have been better. So I guess ki this is our first lecture. This is a curtain raiser, and then we will look forward to more lectures to come, right, sir?
Surely, why not?
So yes. Well, students, my feedback. Actually, you are really lucky to have such an expert from the industry today, talking about the instrument part on the color. He is associated with for many years. Sir is associated with our institute in terms of getting instruments, in terms of training, in terms of software, in terms of all the repairs and everything. For everything we look up to him only. He's very helpful in our projects also. I have myself carried out some projects where he has guided our students. So my feedback is he has covered all the spectrum of the concepts in very simple language, and then the way he was telling, you could easily it was not only the students who were listening, but all the faculty was also all ears to it. So right from the WebGear to the ink formulation software, everything was covered, and it was simplified to the extent he could. So it was great. It's a great pleasure indeed to have you, sir, for covering all these. The students have we have heard for past 3 days we've been hearing about the color, but this was the other side of the subject or topic, because everyone was talking about management and how the color is read and all that. Different types of the color models and all, but today how it has to be measured, which are the instruments, how does it takes place, what is used in industry, everything was covered in very simplified language. So from my side, and I'm really thankful for having you, sir, for today's session.
Thank you,
Thanks a lot.
Padmini madam. Thank you
And
so much for inviting me, and I thank Shrikala madam also
yes,
for the needful. मला वाटतं
Yeah,
मॅडमनी फोन
actually,
केला की लगेच मी त्यांना हो म्हटलं होतं, बिकॉज फॉर
oh,
पीव्हीजी कॉलेज अँड फॉर
yes,
स्टुडंट्स इट इज एनी टाइम. आय थिंक अक्षय जोशी सर
yes,
ऑल्सो विल
sir.
एग्री टू माय पॉइंट. मी कधीही
Sure.
Yes, sir.
आजपर्यंत माझं
Yes, sir.
रिलेशन,
Actually,
जेवढी वर्ष मी प्रिंटिंग इंडस्ट्रीमध्ये काढली आहे तेवढं माझं रिलेशन पीव्हीजी बरोबर पण आहे. सो
yes,
yes, sir.
ऑलवेज
Actually, Madhura madam ni पण message दिला होता that she is in the university for some college work and she could not join, but she is going to listen to the recording in the night when she comes home. So she has said
Wonderful,
sorry that she
wonderful.
couldn't attend today's session.
No,
So,
no,
but yeah,
absolutely
thank
no
you
problem
so
at all.
much.
And in
Yeah,
today's times, you have so many work, but
yes,
एवढी मुलं आली, एवढी faculty आली ऐकायला. I should
yes.
really thank all of you that you have spent so much of time in
No, sir,
listening to
absolutely.
somebody whose face you have not seen. So thank you so much. Thank you so much.
Yes, sir. I hope you are safe in this rain, heavy rain, sir.
Yeah. Absolutely.
Yeah, good. All right.
Thank you so much. Thank you so much.
Yes.
Thank you.
Thank you.
Thank-
Yes. Just a sec. Oh, thank you, ma'am.
Can I leave the meeting or should I wait?
Yes, sir. He's
Thanks.
just going to give vote of thanks and then.
sir.
No problem. Absolutely no problem.
Yeah.
So yes, I would like to invite my friend Pratik Dandge to give vote of thanks. Over to you, Pratik.
Thank you, Rugved. First of all, good evening to all the dignitaries. I am really thankful to Mr. Vishnuu sir for your extremely informative session with us. For sure, all the students and faculty members enjoyed it a lot. We students feel so lucky for getting updated knowledge about color and press instruments from you. So once again, thank you for your valuable time. Hope we will do this type of interactive sessions again and again so students can update their knowledge about all the instruments which are using right now in our printing industry.
Always.
And I would like to thank all the faculty members for their support. This session were impossible without their support. I would like to thank Sandesh for introducing Mr. Vishnuu sir. Thank you Vijay and Shubhangi for the poster designing of today's session. Thank you Aditya, Pranali, Ajay for conducting daily quiz competition after the session. Thank you Ria, Gargi and Pranit for submitting daily report with the small details. And thank you and congratulations to Rugved for moderating today's session with neatly and smoothly. Last but not the least, thank you Srikala ma'am for helping us in every single department for success of this webinar. Thank you so much. Over to you, Rugved.
Okay, so thank you everyone for your hard work.
Thank you all, and I should really say that it has been
again.
very professionally done by all of you. So congratulations to all the one involved. It's a very good professionally done webinar. Thank you so much. Thank you.
Okay, so thank you.
Thank you, sir. Our
Thank you,
pleasure.
sir. Thank you so much.
Bye.
Bye, sir. All right. So students, हे येईलच तुमच्याकडे क्वेश्चन क्विज फीडबॅक द्या. खूप लोक मिस करतायत फीडबॅकला. त्यामुळे न चुकता प्लीज यू गिव्ह युअर फीडबॅक that student will really know where they are lacking. And yes, quiz पण द्या. आय होप गणेश शेळके आणि शुभम नाईकरे मध्येच फायनल होणार आहे असं मला वाटतंय, कारण दे बोथ आर दोघांनी जिंकलेले आहेत टॉप पोझिशनला. सो लेट्स सी आज कोण जिंकतंय. ऑलराइट, you have to leave because we cannot remove you, then you will not be able to join again tomorrow, so you have to leave on your own.